Flack math! Give me some math and I'll give you some flack. Flack math!
All right, this is the last uniform motion situation. So this uniform motion is where D1 plus a constant equals D2. Okay, so let's just start with an example. So at 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. So left south at 20 kmh. Okay, at 10, Patroclus, I don't know how to pronounce that, headed south. Going 50 kilometers an hour. Okay, so if Pat, let's just call him Pat. If Pat was 50 ahead of Achilles at 3 a.m., what was his speed? Oh, wait. Oh, sorry. He did not go 50 kilometers an hour. So he just left south at 10 a.m. It doesn't say how fast he was going, okay? So this is where I got the 50. If Pat was 50 kilometers ahead of Achilles at 3 a.m., what was his speed, okay? So don't start mathing it. Let's just plug it into our equation. So this is a situation where we have the distance of one person. So the distance of Achilles plus a constant equals the distance of another person. So distance of Pat. So see how this says Pat was 50 kilometers ahead. So if I drew this diagram here, so here's camp. So at, what was it, 8 a.m., Achilles left. And then at 10 a.m., Pat left. And this is where it ended up at 3 a.m., okay? So this is 50 here, so you can see that, oh, okay, so it's basically Achilles' distance plus 50 has to equal Pat's distance. Okay, so if it helps, draw a diagram, but this is the other scenario. So remember, we have a scenario where the distances are equal to each other. We have a scenario where they both add up to a constant. And then now this scenario is that one of them is a constant apart or ahead or more. Okay, so let's find some R's and T's here. So the only rate we know is Achilles' rate is 20. We know both of the times because they left at 8 and we want to know what's happening at 3. So that's 4 plus 3 is 7 hours for Achilles. And Pat's time was 2 hours less, so 5. So Pat left at 10 and we want to know what's happening at 3. Okay, so that's nice. That gives us 3 numbers for these variables. So we're going to replace the D's with R's and T's. So let's do that. So the dA is just RATA plus 50 equals RPTP. All right, RA is 20, TA is 7. That's a nice left side there. RP, we don't know, but TP is 5. So I'm going to say 5RP. So just solve this. What is that? 190 equals 5RP. Divide by 5. RP equals 38. Okay, 38 kilometers per hour. So we know that he has to go faster because he ends up ahead of Achilles at a certain time. All right, so this scenario, there's a couple other examples here. Let's do another example. All right, Rachel began 15 kilometers ahead and they ended up in the same place. Okay, now this sounds like a different equation, but just bear with me. Oops, I'm writing part of the solution and not the problem. Ahead of Charlene. Okay, how long will it take Charlene? How long? So it's asking for a time. To catch up if Rachel sorry, so this looks like kilometers per hour. So this is, yeah, this is just 15 kilometers ahead. I think I said kilometers, but I wrote kmh. If Rachel travels at 70 kilometers per hour and Charlene travels at 100. Okay, so how long will it take her to catch up? All right, so let's just draw a diagram. So here's the start. So Rachel begins 15 kilometers ahead of Charlene. Okay, so if this is Charlene, Rachel is 15 kilometers ahead before she starts. Okay, so this is, and they end up in the same place. So this is the distance of Rachel. So it's still this situation where D of R plus 15 equals D of C. Okay. All right, let's find our R's and T. So R of R is 70. R of C is 100. And then we want to know what time, but it looks like they started at the same time and ended at the same time. So basically our times are the same. So you can keep a subscript if you want, or you can just say, well, TR equals TC, or just say T, because since their times are the same, then you only have one time you're worrying about. You don't have to subscript it. Okay, so let's replace this with R's and T's. So RR TR plus 15 equals RC TC. All right, so our RR is 70 and TR is TC, or just T, plus 15 equals RC, which is 100, then our T again. Okay, so this is a nice equation. There's variables on both sides, so get rid of the smaller one. So 15 equals 30T. Don't do this too fast. It's not 2. Divide both sides by 30 and t equals 1/2. Okay, so it looks like a half an hour is how long it'll take Rachel or Charlene to catch up. Okay. All right, so let's see, there's one more example. We can do it if you want. Let's try that. Let's see if you guys can try this one, okay? This is example 3. So later, if you need help, you can go through these and they kind of list out the solutions for you in the book. It's kind of nice. But Harry and Janet, not Janet, but Janet, jog around a circular track. Uh-oh, this is going to mess up our diagram. Around circular track. That is 210 meters long. Or, yeah, 210 meters around, I guess. So if Janet's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute, in how many minutes will Janet be a full lap ahead? Okay. So Janet's rate is 230 meters per minute. And then Harry's rate, 20 meters per minute, or 200 meters per minute. And how many minutes will Janet be a full lap ahead? So that's an interesting one. So here's the lap thing. Like, I'm tempted to just not do that. So this is 230 meters. So we want to know a full lap ahead. So let's say we just make that straight, okay? So we've got like our typical starting place here. And here's the distance of Janet. We're both starting at the same time. And it looks like here's the distance of Harry. And it's a full lap ahead. So how much is a full lap? It's 210 meters long. Okay, so here's our equation. So see if you can do that.
Micah, you got something?
Janet will be ahead for 7 minutes.
What is that?
7 minutes.
Do you want to repeat that, Mrs. Waite?
Yes, he said 7 minutes.
All right, good job, Micah. All right, so some of these you guys can probably just figure it out, but let's write our equation here. So we're going to try to put it all right here. So d of j, or d of h plus 210 equals d of j. So that means RHTH plus 210 equals RJTJ. All right, and it does look like their times are the same again. So I'm going to say time of H equals time of J. And it does give us our rates 230 for Janet. And it gives us 200 for Harry. All right. So let's see. 200T plus 210 equals 230T. All right, get rid of the smaller variable term. 210 equals 30T. So T equals 7. Good job, 7 minutes. All right, so that's the last uniform motion scenario. Any questions with that? Do you guys feel okay with that? Again, you can kind of cheat it a little bit by in your homework. You'll see which unit. If it says 99 in parentheses, then that's the scenario where there's a little bit ahead. But try to figure it out yourself. Try to match it with one of these three scenarios before you look at that number in parentheses. Okay. And on the test, honestly, when we take a test on this stuff, first of all, this won't even be on the test because it's not, our test is going to go up to less than 95. On the test, whatever is on the practice test ends up being the same scenario on the actual test. So don't stress about the test. All right, we are going to do 100 now. The last one we're going to do, but not the last one in the book, obviously. Lesson 100. This is a historic event here. Okay, so this one's actually called place value and rounding. Well, you guys know how to do this, but let's backtrack a little bit here. And this is really comes back to our number theory too. And if you think about the number system, it's pretty amazing. But it's just 10 symbols that basically put together in the right order gives you an infinite number of values. And with a decimal point, oh my goodness, and just infinite number of values in between those infinite number of values. So the whole system is pretty amazing. Okay. So lesson 100, I don't know why it does this, but it's just rounding decimals. And so let me see if there's anything tricky about this at all. Yeah, there's not anything tricky. So I'm just going to do these examples, and most of you probably know how to do this, but if you don't, this is a good catch, because you don't want to go into higher level math classes, or especially higher level science classes, without knowing how to round decimals, because you're going to be rounding a lot of numbers, and a lot of times you'll be rounding to the nearest hundredth. And but let's do some examples here. Let's make sure you guys know how to do this. I want to round this number to the nearest 10,000. Okay. So round that to the nearest 10,000. What makes it a little different than basically pre-algebra or math 7 is that it does have some lingering decimals on the end. So what do you do with those? All right, does anybody have an answer? Nearest 10,000?
Go ahead, Micah.
27,250,000.
Okay, can you repeat that? Or Mrs. Waite, can you repeat that?
27 or 47? 27.
47.
47,250,000. Is that what you said?
Okay, so I'm glad we caught this. No, that's not the right answer. So basically, rounding, to put simply, is trying to figure out It's in between two of these 10,000s. Which one is it closer to? So if I were to graph this on a number line, it would be in between 47,250,000 and 47,260,000. And which one is it closer to? 250,000 or 260,000? Well, this 8 says it's more than halfway. So it's closer to the 260,000. Okay? So this is good. So I'm going to put these up here. You guys probably remember something like this. But for some students, this comes freakishly natural, like it's like they just see it. For other students, for me, but this is how I do it. I mean, I just need a formula, and it's nice to have a step-by-step algorithm here. So what we're going to do is we're going to circle digit that we're asked to round. So we're circling digit we are asked to round. Okay, so that is the 5 here, because that's in the 10,000s place. All right, and then we're going to, this is what, I know it's silly, but we're going to put a little arrow on top of number digit to the right. Okay, the only reason we do this is now it's easier to describe what we're doing. Digit to the right. So we're going to put an arrow on top of the 8. Okay, so if, and this is our scenario, if arrow digit is 5 or above, then add 1 to circle digit. Okay. If it's 4 or below, if arrow number is 4 or below, then you keep circle digit the same. All right, and then the last step, if you're rounding whole numbers, change all digits to the right of circle number, that looks like a smiley face, to zeros. And then a little cleanup thing is drop off any lingering decimal zeros. And that's not really a term, but if you have zeros on the right and you ended with a decimal, then you can get rid of those. Okay, so we're changing this 5 to a 6, and then we're changing everything else to zeros. And then what we can do is, since we have 0.000, we can ignore those. So 47,260,000. All right, let's try another one. Here's our steps to rounding. So I'm going to round this number to the nearest thousandth. Okay, see if you can do that. To the nearest thousandth.
Anybody got it? Elkin?
Is it 104.063?
All right. So you went the other way this time. So we're going to circle this. This is the thousandth, right? And then we're going to look here. All right. Apparently, I didn't go over this well enough. My bad. So this is 4 or below, so we're going to keep it low. Remember, 5 or above, give it a shove. 4 or below, keep it low. Okay. But this number determines what to do with this number. Okay. So this is 104.062. And then we've got zeros there, so we can just ignore them since they're after the decimal. Okay, does that make sense why it's 2?
Because the 4 was below 5, right? So it doesn't bump it.
But doesn't the 5 bring it up to another 5?
What 5? This
So
5?
Yeah, doesn't that round that 4 up to a 5? And that,
Well, if you were rounding to the nearest 10,000th, then yes. But if you think about this big number, anything below 5 anything is going to be closer to the 0.062 instead of 0.063. So you're only rounding once. So now if you were to round this, yeah, and then round it again, then it would be, but that's not what rounding is. So you're just rounding once, okay? All right, let's do a couple more since we are our success rate isn't what I want it to be. So example 3, we're going to round this guy. To the nearest 100 millionth. That's a mouthful. So this to the nearest 100 millionth.
Go ahead, Micah.
0.0004139.
All right, let's see here. So let's find the 100 millionth. So 10th, 100th, 1000th, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth. Okay, so this is what we're circling. This is what we're looking at to determine whether to keep that low or give it a shove. And that 5 says to add 1. So yes.
Yeah.
Okay, and then you can drop those zeros. So just a side note, I know that we've done this in the past, but how would you say this number? I mean, the other acceptable way to say it is what I think you just said, Micah, 0.0004139. So if you list each digit and don't try to place value anything and just list the individual digits after the decimal, that's okay. That's how people say it. Just don't say 0.00041,379. Or don't say that. But there is another way to say this. Do you guys know how to say this?
Go ahead, Nathan.
41,379, 100 million.
Yep, that's right. Okay, so you either have to do one or the other. Like for example, you can't say 0.58. You either say 0.58 or 58 hundredths. Okay, but don't say 0.58. All right. So I think we've exhausted that. There's let's see if it gets any trickier. I don't think it does. It's tricky to turn the page for apparently. Okay, and then it might say to 5 decimal places and things like that. The only time it gets really tricky is, let me just skip to example 5. I'm going to round this number . to 5 decimal places. Okay. So round it to 5 decimal places. And then it says like to 9 decimal places to the nearest 100th. Okay. So let's just try to, let's just say 9 decimal places. Sorry. We're going to round this to 9 decimal places. So if you're doing this, then first of all, there's only like 4 decimal places here, but this little repetend here means that it repeats. So I'm going to just write as much as I think I need. 3, 6, 4, 3, 6, 4, 3, 6, 4, 3, 6, 4. Okay. And then I'm going to count over 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm just going to follow the steps. So that 4 says keep that 6 the same. So final answer. Boom. Okay. Does that feel all right? All right,
Yeah.
guys. That is Algebra 1. Sorry I can't be there to celebrate with you, but we will review for our final test next week. We'll take 2 days to do that. So we're going to take our time, make sure we understand everything. And then the following week, we will begin taking our test. And I'm going to give you guys plenty of time to do that. And ultimately, you can take it home because your online student cohorts are also taking those at home. So I don't want to be unfair in that way. So any questions? Yes, Elkin.
Are you still doing the thing where if we have an A in the class, then we don't have to take it?
Yep, and I'll let you know. But you still need to do your practice test. So I would take your practice test, and that's only going to help you to get it done early anyway, because you can get extra credit on that. Whether or not you take your test or not, you're still going to get extra credit in the participation grade. Okay, so get that test done by Tuesday, and I will go over 10 questions on Tuesday, and then I'll probably either Tuesday or Thursday let you know if you need to take the test. But that's it. All right. Any other questions?
Flack